equation of a parabola that has two x-axis and a maximum value of something. My bad. Include a graph of your parabola. Okay. So parabola is the curvy thingy.
Curvy thingy.
Yeah.
Do you remember the different forms that a parabola could be graphed in? I know I taught 3 different ones. Did your teacher ever talk about different forms quadratics could be in?
I don't think so.
One of them is standard form.
Okay.
We looked at that on number 3.
And then one of them is the y equals something.
Something very specific.
Yeah.
You could do intercept form or vertex form. Have you heard of these before?
Yeah.
Okay, any of them in your noggin?
No.
Awesome. All right, so do you remember, so if you're looking at a quadratic equation, what makes it open up or down?
It's positive or negative?
What's positive or negative?
A.
Okay, so you're remembering an a value. So let's talk standard form then.
Okay.
So ax squared plus bx plus c. You're saying if a is positive or negative, it opens up or down. What does a maximum mean?
Maximum is like the greatest like point. And so it's like if it opens up, then like the vertex wouldn't be the maximum, but if it like opens down, then the vertex is the maximum.
Okay, so which way do we want this parabola to open?
So write an equation of a parabola that's 2x. Oh, and a maximum. So we want it to open down.
Okay.
Because then we can define what the maximum value is.
So we want it to open down, so what kind of a value are we going to have?
A negative.
Okay. So maybe let's start jotting these clues down, because this will help us build an equation.
Okay.
So what have we decided so far?
That, so it has to open down, and the a has to be negative. And then the vertex has to be like the maximum. So it has to be like the highest point.
So what else do we need to accomplish in this problem? We
have to find 2 x-intercepts, so
we don't have to find them, we just have to show that there are 2 x-intercepts.
Yeah.
What's another word for x-intercept? Or where do those happen?
Well, it happens where the parabola, it like hits a point on the x-axis.
On the x-axis, okay. So do you know any other words for intercepts?
No.
We might call them zeros or roots or solutions.
Okay.
So you're looking for a quadratic with how many solutions?
2 solutions.
2 solutions. Interesting. How can you create a quadratic that has 2 solutions?
Well, you could do like negative 1x plus negative 1x squared plus 2x, like plus 2 or something. Like
so write that down.
Okay.
Tell me how you thought of negative 1x squared plus 2x plus 2.
I tried to keep the numbers like lower just because then it's going to be like really high up on the y-axis. And then also so I could find points on the x-intercept without it being like at like negative 42 and 42.
Okay. How do you know that there's 2 solutions?
I don't remember.
Do you know how to use your graphing calculator to see what that's going to look like if you graph it?
No.
Okay, I'll show you. Everything that you need for graphing land, have that's up here. So if I go to graph, go to y equals, and we're going to type in your equation. So what equation did you come up with?
-1.
And on this, you actually have to use the negative symbol, not a subtraction. It's going to be mad at you here.
Oh, so there's a negative symbol?
There is. It's down here.
-1. And then do I have to do like alpha to do that?
Do x.
Is that how I do it?
Alpha x, because you're actually going to use this button. X. And then how do you make it squared?
Plus 2.
What's that variable? Yep.
All
right.
And then graph.
Go ahead and hit graph. Let's see what you made. And probably.
And apparently the recording got cut off, so she noticed there were two solutions, accepted the graph, and made a sketch.
Fun, we're going to go over the answers here. Number 1, do you remember what it means to square something?
Well, I remember it means that you have to apply it to everything in the parentheses.
Sure, but what does squaring actually mean? The definition of to square something. Don't even look what's inside of it. What does it mean to square? Double. It's something times itself. So what is the something we're timesing by itself?
X.
X.
Or x plus 2.
So if I'm taking x plus 2 and I'm multiplying it by itself, what am I multiplying it by? What is itself? X plus 2. Okay, so I'm taking x plus 2 times x plus 2. This looks familiar. All right, so what is x times x?
X squared.
Okay, what is x times 2?
2x. And then plus 3x. Plus. Plus 2x. Plus 4.
Got it.
To be x squared plus 4 plus 4.
Squared plus 4x plus 4.
Isn't, because like we learned how to do that, and then he told us like a shortcut where we just like.
There is a shortcut.
Oh, but I didn't double it.
I didn't double it. Okay. Okay, so I see where you were thinking there. I could tell that you knew some sort of pattern.
Yeah.
But sometimes the shortcut actually hurts you, because if you don't remember the shortcut and what it actually represents, you can always count on what is the definition.
Yeah.
To square something is to rewrite it out. So if this is your problem, you said subtraction. If I'm subtracting x squared plus 4, I have to write in or understand I'm subtracting all of that second term.
Yes, it's a negative.
And so then x squareds do cancel, the 4 and the negative 4 do cancel. Are you left with the exact same thing on both sides?
No.
So your answer was right, and I like that you like, I knew my answer was right, but I don't like my reasoning.
Yeah.
So that was a good thing for you to recognize, and just, that's what would have fixed it. Okay. Number 2, oh boy, you had all the right steps, and guess where? Parentheses would help. Why are parentheses needed in 5x minus 2x plus 3?
So it's for this.
Why do we need parentheses?
Oh, because you have to subtract everything and then 2x minus 3. You don't just have to subtract the 2x.
And so what else needed to be fixed there? Look at your other expression.
Oh, I also need to add parentheses here.
Okay.
Because it is supposed to be 7x minus 6 and then parentheses for the 4x plus 5.
Because you're subtracting both the 4x and the 5. And so that again would be a distribution of a negative. But you have the same process. You were doing too much work here, but that would have gotten you the right answer before you started designing right terms. So just make sure you try to be nice to yourself. I always tell my students, if you ever feel like your head's going to explode, there's an easier way to do it. So take a pause to see. So that would get me the right answer here. Awesome thoughts here. I could tell that you really wanted to undo that square first, but always check back. Factoring is going to be useful, especially in algebra geometry. All right, so graphing wise, when you have two solutions, the easy way to kind of think through some nice ones, two nice solutions that you want to use. What two nice intercepts could you think of?
1 and 1.
Okay, so if your solutions are 1 1 and what else?
1
That's
or negative 1.
okay, if they're 1 and negative 1, what would their factors have been? So if your answer is 1, it's because x plus 1, or excuse me, x minus 1 equals 0.
And then
If your answer was negative 1, it's because x plus 1 was equal to 0. So that means that your factors, and you want your a value to be negative, so you kind of start working backwards here. What's x times x?
x squared,
And x times negative 1,
negative 1x,
and 1 times x.
negative, or, x.
X and 1 times 1, negative 1, sorry.
Yeah.
And if I want a negative on the outside of it, are there any like terms that we can wrap down to?
Yeah.
So I've got x squared on minus 1